Hello and welcome to the first in the series of product design and manufacturing collections, Inventor add-ins. First up we have Inventor tolerance analysis. In this presentation we'll be taking a look at this simple gear assembly where all the components have been modelled to the exact size. However, we all know that once sent through to production, we could see variations in sizes due to the manufacturing process. We're now going to take a look at our gear component. By specifying a tolerance feature found in the geometric annotation panel, we can specify our tolerance of each face on our gear. Adding a value of 0.2, doing the reverse side, we'll find that now when we're adding this, that both tolerances are linked together. Now we've specified our tolerances to the two gear faces. We can add a general annotation dimension from one face to the other, which is a value of 24. No need to add a value for the tolerance as these are already specified, and just selecting the basic tolerance is all we need to do. Okay, let's now jump back into the assembly and start our tolerance analysis study. Once we're in the tolerance analysis study, we need to start a new stackup, and we can do this by first off selecting the tool and then selecting the faces we want to inspect first. And now select the annotation plane, which can be a user plane or an origin plane as this example shows. Once we place the dimension, you'll find that one path has been found through all of our components. Now this is based on the constraints that we've used within the assembly. It now goes away and builds up all those dimensions for me. Of course you can select the components manually, but for this example we're just going to use the automatic loop function. Tolerance analysis has taken our 3D annotation information from our model and populated our grid, so we can use this information on our stackup. Now let's specify our upper limit to 0.35 and start interrogating our stackup. I'm going to start by taking a look at the two annotation tolerances we placed earlier in this example. You'll see that we'll have the link symbol, so changing one tolerance will change them both. It's worth mentioning at this stage that we're still working in the worst case scenario. So although we're changing these tolerances now, we can still have a very good idea if all of these components were built to the max tolerance, would we have an issue? And it's still showing yes we would. So now let's change the dimensions, upper limit and lower limit. And it's starting to look a little better. But again, remember, this is worst case scenario. And let's investigate this even further and look at the contributions each component's making to these results. It's really important at this stage that we understand that any minor adjustments to tolerances can have a huge impact on machining, increasing production time. But this is the worst case view, so let's take a statistical view. Drop it down this menu. This view shows us what the probability is, or what the chances are, of all of these components being picked and assembled together. In this example, we've done enough work to make sure that all of our components will fit. And all what's left is to create a report. So first we take a snapshot, which we can use in the report, hit generate report, save it to a folder, and with the report we have our newly created snapshot, all the tolerances in the stackup that we've created, our dimensions. We can now take our report down to manufacturing and have that meaningful conversation and find out if the tolerances we've added are acceptable for the manufacturing process. I hope you found this brief introduction into Inventor tolerance analysis useful. If you do have any questions, please reach out to us and we're happy to help. Tune in next week for the next session on Autodesk Inventor CAM. Thank you.